First, Professor, Department of Computer Science with text processing frameworks. Yeah. And before we start for this class today, I would love us to pray first according to your own religion and belief. So everyone, let's pray start together.
Madam, when shall I start?
Yeah. Yeah.
When shall I start?
No, we will start.
Is it okay? Right time to start?
Yeah, you can start for class today. Thank you.
Okay, ma'am. Just a minute. Just I'm setting up the PPT. Just a minute, madam. Shall we wait for another couple of minutes, or shall we continue?
Yeah, you can start for this class today, Madam. Yes, sir.
Because people are joining every now and then.
Yeah.
It's very difficult to admit for me. Can you admit? Do I have that control to admit people?
Oh, wait. You can start screen your PPT. Okay.
Is my screen visible, madam?
Yes.
Is this visible to all of you? Yeah. Okay. So what's the total participants expected, madam? Total participants expected. Shall we start or shall we wait for another couple of minutes so that participants can join? Hello, madam?
Yeah, you can start now.
Okay.
Okay.
All right, guys, just a minute. Yeah.
Yeah.
Is this visible? Okay. Last confirmation. Is this visible?
Yes, we can see your PPT.
Okay. Thank you. Thank you very much. So let me first welcome all of you to this presentation. A hearty welcome to all of you for this session on frameworks for text processing. So I'm Paramesha K, professor in the Department of Computer Science and Engineering at VVCE Mysore. So here is the outline of this presentation. So I will be presenting my perspective in processing the text. So what are the different models that were evolved, and some insights into some models which are associated with the text processing, and finally the main mojo will be the demo of some of the NLP applications, right? So this is the outline. So you can say this outline can be divided into classical models and deep learning models, because now if you look at the era, it is all about deep learning models. So whenever we do any natural language processing, so invariably, most of the times we use the deep learning techniques that can give a very good performance in almost in all NLP applications. So this is actually the outline. So as I said earlier, first we'll see what are the classical models, and then we move on to deep learning models. Of course, whatever I am going to say is just a tip of the iceberg. So it is a very vast field, by itself. and we have a lot of applications in this particular area, especially text processing area, right? So let us see what is the NLP task. So basically NLP task is divided into analysis task and generation task. In fact, when we talk about text, so even we have text mining. So that is completely different. So what we are talking is NLP, natural language processing. So this is the definition. This is the task that we are having under NLP. So both analysis task as well as generation task. Whereas in text mining, it is more concerned with the identification of patterns. So that is entirely a different domain. So what we are concentrating here is the NLP, that is natural language processing. So where we need to analyze the contents of the text. We need to understand the sense of the text. So we have both syntactic, that is tokenization. Tokenization comes in different at different levels. Say we can have sentence tokenization, word tokenization, and so on. So even semantic meaning. So that is where we need to understand the sense. What is the sense? The sentiments, the emotions in that particular sentence. So both sentence level as well as the document level, we can have the sense. So also we have pragmatic analysis, wherein we'll have word sense disambiguation. See, many of the words, they are same, they are homophones, they actually different senses are there. Depending on the context, we need to consider the relevant sense. Say for example, bank, we have a financial institution called as bank, right? And we also have a river bank. So depending on the context, so we need to consider the meaning of that particular word. Say for example, bat, we have animal called bat, so flying mammal, that is bat, and also we have that cricket bat, right, used in sports, right? And coming on to the generation task, so basically we are giving some input and we are generating some output. We are synthesizing. Here generation means synthesizing. Say for example, machine translation. So translating from one language to another language, you need a very sophisticated knowledge model. So to translate the language from sentences in one language to another language. That another language, we call it as target language. And the input that in which we give is called as source language. Likewise, question and answering. It's not easy to generate or synthesize the answers. So we're going to see some demos on this generation as well as analysis task. Of course, language modeling is also there. So wherein, in language model, so if you have a model, so you can predict what is the next word. Given previous words, so you can predict what is the next word. It's all about knowing how the words will form the sentences. Is it going to be a valid sentence? Is the sentence is going to have a meaning in it? It will whether it is going to make sense for us or not. Okay, so that is about the language modeling. So basically, words, we are playing with words and its meaning. So for example, if you look at the sentence like cat sat on the mat, so that is a probably that is a probable sentence. So this sentence makes sense, right? And for that you will get the probability. Using language modeling, you can assign probability. So the word sat is actually a right word that can use in that particular sentence. That's why probability is more. Whereas a cat sat on the mat, that is not a meaningful sentence. That does not make any sense. So the probability is just 20%. So here, given the context of the other neighboring words like cat, this side we have on the mat, this side we have the cat. So that current word, that is sad, whether it is a right word or not, so that we are actually deciding in the language modeling. So language model will give what is the probable word that can fit in that particular context. All right. So if we have trained the model in an efficient way, then definitely it can able to give some words, probable words that can fit into that context. Right. So this is an example. So if you look at the other example, like I wind tonight, I wind tonight. Yeah, it is a meaningful sentence. Whereas large wind tonight, even though large is, it's a superlative noun. I mean, adverb. Adjective. Still, it's not a, the probable usage is very, very less. So I is a better one. Similarly, if you consider 5-gram word, say for example, can you please come over here or here? So that makes sense. So what is the right word in that particular, in the last word, what is the right word that can be used? So it cannot be any other word. Okay. So we have few words that we can use. Here is a better one, better option. Okay. Can you please come here? So that is, the language model that we need to, develop in order to predict the words based on the context. So here the previous 5 words, we call it as contextual words, right? So guys, this is the classical NLP that we were using a few decades back. So in this, we are having input documents, and we have language detection. What is that language for which we do tokenizing? Okay, we do pre-processing. See, all types of pre-processing we can do: tokenizing, assigning tags, that is parts of speech, then removal of some unwanted words or most frequent words like stop words. Likewise trimming, right? So many pre-processing we can do, and finally after that we are doing modeling. So depending on the output, downstream tasks, so we can do different types of modeling. So we'll see what is the modeling, so how we can model. So basically modeling means translating the text into machine numericals, so that machine models can able to understand that one. So as it is, it cannot able to understand. So we are translating the text into some numericals that represents the weight for the text, so that you can perform some downstream tasks like sentiment analysis, then name entity recognition, so classification, text classification, topic modeling. So many tasks we can do. So all these things are called as downstream tasks. Once modeling is done, you can go for doing downstream tasks. So basically modeling means converting the text into its numerical, okay, a numerical representation of texts. So that was what we followed in the classical NLP. Even today we are using NLP, but it is an era of deep learning models. We use deep learning for better efficiency. So this is the layer for architecture for deep learning based NLP. Here we do pre-processing. We remove some words and all, and we are directly giving to dense embedding. So basically the main feature here is we are converting each word into its embedding. So we'll come to that later, what is embedding, and that is fed to the deep neural network. And finally we can able to do the classification, recognition, all these things you can do it, using this model. Here main attraction, main changes are the main takeaway here is the word embedding. We are using word embedding, so we'll see that later how what is word embedding, how it is different from other weighting schemes and so on. So this is about deep learning. So we use neural network, and for the neural network we use word embedding. It is not just a numerical of a single value. It is going to be a vector. For each and every word we are having the vector which represents the word in different contexts, right? So we can do a lot of tasks using deep learning models. So in the end we're going to see very good demo of all the models, right? So this is about the architecture of transformer model, wherein you can able to use this one to generate or synthesize the text. So as I said, you give the input in one language, that is source language, and you can get the translation in another language. So it can be question and answering, it can be machine translation, you can have something like that in so many ways. Here we are giving in one language, maybe French we are giving, and we are getting the output in the English. So this is encoder and decoder architecture. So this is a latest one. In fact, even we have passed this model, and we are coming up with sophisticated models, right? So every day you are going to see the milestones, right? In the earlier, when the NLP was introduced, we were having this kind of term document matrices. So the documents are represented using vector space, right? So this is what we call it as modeling, term document matrix. So this was used when NLP was at infancy stage. So this you can see the words and the documents, and we have frequency of these words in each and every document. So this is a simple weighting scheme that we can use for modeling the documents. Like complexity, you can see here in D1, that is document 1, we have 2 frequency is 2. So occurrences are 2. So that for each and every word we can have the frequencies. This is term document matrix. This is a simple representation, vector representation, right? So you can see here another improved version over the frequencies is term frequency inverse document frequency. This was widely used some time back for modeling the documents, and here this gives more better performance compared to other weighting schemes. This is also weighting schemes that is based on the overall occurrence of the word relative to the document as well as the entire corpus. So that is how we can understand this term. So you can see the document 1, we have token that is term 2.5. So this is a single value that is assigned to the token 1 in D1. Okay. So this is based on the term document matrix, I can able to evaluate, I can able to get term frequency inverse document frequency matrix. And we have there were so many variants that were developed, okay, around this concept for better efficiency, right? So this was one of the weighting schemes. And in all of this, if you observe, for each and every document, there is a single value that is assigned, right? Single value, right? It's not a vector. For one token, one value, okay, for each and every document. So it is going to be one value. So here, if you look at this, the value distribution of TF, IDF, we are not considering the value which is low because they occur frequently. So that's why we remove all stop words and all, and even rare words which are very high, because the frequencies are less. So it is inverse document frequency. So we concentrate on most frequent words. So this is high frequent words. Stop words are high frequent words. So we are taking the words which will fall in mid range. So that will be of greater use in the computation, right? So that is about TF, IDF value. So even we have latent semantic analysis, allocation, right? Or analysis, you can say, where the term document matrix is factorized into topic and topic distribution over documents. So here you can see the matrix is factorized into word assignment to topics. That means what is the word, this topic distribution, you can say. So for each and every topic, what is the words that we can have, right? And what is the topic importance and topic distribution over documents, right? So you can get the factorization, and using this, I can able to judge what are the words belonging to each and every topic, and what is the topic density in each and every document. So if the particular topic is more in that document, I can categorize the document, okay, based on the topic density. So all such things are there. So bag of words, can be modeled using LSA and negative, modeling is there to remove negative values, and LDA, latent directionless allocation. The LDA is most sophisticated compared to LSA. So basically, a given document can be assumed as a mixture of topics. So the predominant topics in the document, we can able to determine, and you can able to classify the document based on the topics. So as you can see here, based on words, you can have the topic distribution. So it is all about modeling. So we assume the document as mixture of topics, right? A document can have mixture of sports, entertainment, politics, and so on. So if entertainment is more, the distribution is more, then we categorize that document into entertainment class. Okay. So we are having this one-not vector. So usually when we are giving the input in a corpus, the collection of various words, we call it as vocabulary. So using one-not vector means the corresponding word, the corresponding word is set 1 in that vector. So that is one-not vector. So out of n, we vector components, only one will be set 1. That will indicate the corresponding word. So this is about the one-not vector, which is very important when we are evaluating, when we are generating word embeddings. Okay, this is the source, this is the input that we are giving in order to derive word embedding. So now let us see what is word embedding. So you can see in the word embedding, we have different frameworks for generating the word embedding. So we have two frameworks: Word2Vec, that is given by Google, and then we have global representation for words, that is given by Facebook, right? So two frameworks are there where each and every word in the sentence in the corpus is going to be translated or converted into a vector. You can see the vector for each and every word. So we have a king, man, and woman. For each of these, word, we are having vector. So that is the milestone. That is, it has revolutionized the downstream tasks. So this helps in getting a better performance, because earlier you used to have one value for each and every word. Now we are having a vector. So this vector is nothing but a collection of features. You can say collection of features. So you can say collection of context in which this word can be used, right? So each word is having fixed number of components. So it can vary from 50 to 300. In Facebook, in the globe, we have 200, vector of 200 or 300. Okay. So depending on our requirement, you can select the word to word embeddings. So this is how the word embeddings will going to map. And from this graph, you can see the quasi similarity between words. You can guess, you can able to determine. So you can see here the person J, person 1 and person 2, you can get the similarity. So depending on male or female, you can will get the similarity. So another look on the word embedding, relation between words. So walking and walk, they are related. They are very near. The distance is smaller compared to other words. Swimming and swam, right? So woman and man, okay. King and queen. Queen and woman, you can see here, there, the distance is, very small compared to other, words. Okay. So queen and woman, if you see, this is very small. Similarly, king and man. So the king usually, is male. So the man, it is having, the similarity wise, it is, it is more, right? So this is about the word embedding. I hope you have understood what is word embedding. Word embedding means for each and every word, we are having a vector, a collection of components, okay, numericals, right? We are having. So using that, you can able to do many tasks. So that is going to give a better performance. So we have two strategies for generating word embeddings under word2vec. So it is given by Google. So continuous bag of words and skip gram, right? So here the main difference is the current word based on based on the context, we are going to predict the current word. We are going to model in such a way that it is going to predict the next word or the current word based on the context. Context means neighboring words, right? So neighboring words we are going to use to predict the current word. Whereas in the skip gram, it is going to be opposite. So using the current word, we are going to predict the neighboring words or the contextual words, okay, in that sentence. So if you do that prediction, if you iterate over all the sentences, then model will be fine-tuned and you can able to get the word embeddings. So this is a typical layer, shallow layer of neural network that we can use to convert input or the words into its word embedding. Where can I get the word embedding? How do I get the word embedding? It is very simple. You can see in this case, just have a look at this. This is actually the skipgram, word2vec, right? So we are predicting the current word. This is called as current word, and whereas the input is the contextual words, right? Contextual words are used to predict the current word. This is a shallow neural network that we are having. So this is another model, that is skipgram. So in the skipgram, you can see we give current input, as a the current word as a input. We are trying to predict the contextual words. That is the opposite of continuous bag of words, right? So once we get the last function, we back propagate and we fine tune the weights. Now, if you look at this architecture, now this weights between input and the hidden layer, that will going to serve, that will going to be used as a word embedding. So for each and every word, we are having this matrix, right? So this is a skipgram model. So we are going to give input one word and we are going to predict the contextual words. So while predicting the contextual words, we are going to get the loss, and the loss is back propagated in that, as we do iterate over all the words, right? This is going to get fine tuned. And finally, what we are left with is the word embedding. So you can see here for each and every word, each and every row, it is a word embedding. So here word embedding is 3. So one word we are representing using 3 components, right? So now if you do anything with the NLP, better go for word embedding. So it is going to give the better performance. It is going to give, it will enhance the performance, and also you can do wide variety of tasks. Okay. So don't you rely on classical models. So you can rely on word embeddings. So anything you do, it's going to be word embeddings, right? If you do sentiment analysis or any other kind of classification task, go for word embedding. So you can use either word to vec or glow, or even you can have your own word embeddings. You can generate your own word embeddings. For that, you need time, you need hardware, better hardware. Now, if the corpus is huge, then you need hardware for generating the word embedding. Already readily available embeddings are there. You can use that and for many of the tasks, right? So hope you have understood this technique in generating word embeddings. It uses shallow neural network, and this weights between input and hidden layer, that is going to be the word embedding that we can use, extract. Okay. So this is how errors are computed. So what do you mean by error or loss? So actual minus the prediction. So that will give error, and that is back propagated. So if you are using neural network, the weight should be computed, should be reweighted using back propagation algorithm. So this is a comparison that we are having between word embedding and TF IDF matrix. Already said many things about both of these. So word embedding is better compared to TF IDF in all respects, right? So of course, memory wise, TF IDF is very less intensive because only one value per word. But if you look at the other advantages, it is going to have more. Now, again, coming to the word embedding, right? So this word embedding will have same meaning, same word embedding for all the words, in different contexts. You can see a cell. Cell will have same word embedding, in this sentence, even though they are different in the, they are used in a different sense, right? So here, whether it is having n sensors or m number of sensors, doesn't matter. All the in the word, okay, same word will have the same fixed word embedding. So that is the problem with the word to vec. So polysem means having same words with different meaning, different context, the meaning may change. So that's why higher models, right? The models that were evolved, like BERT models and all, they use their own, context-sensitive embedding. So in this context-sensitive embedding, so each word, depending on the context, it is going to have different word embedding. Thereby, you can easily distinguish what is the word in what is the context, right? And so on. So this is contextualized word embeddings is much more powerful than just word embedding. Okay, so word to vec and glow, they are just word embedding. That means for any, if you take any word, the word embedding is fixed. So it doesn't make any context. Okay, there is no contextual information. Of course, between words it is having, but overall, if you consider, the context is for all. Okay, so these are the many topologies that we can have in the deep learning models. So we can have many topologies like one-to-one, many-to-one. So one-to-one means you can have one input, one output, that's it. And here we use many-to-one for classification. So many-to-one means you are going to categorize the sentence, predict the sentence sentiments or class of the sentence. Many-to-many for synthesis, for question and answering, for machine translation. So all these things, you can use many-to-many. So this is going to be for this, especially this many-to-many, first many-to-many for synthesis, for translation, machine translation. So whereas many-to-many, this is going to be for tagging. So pause tagging, so many taggings you can do. So pause tagging is very important. So assigning tags, parts of speech. So this is a example, typical example of deep learning model using LSTM or gated recurrent unit. So we are having words. Words is converted to embedded layer and given to LSTM. So it can able to process and it can able to give the output. It can able to predict. So this is a example for pause tagging. So wherever sequential data is there, you can use sequential model, deep learning model like LSTM, RNN, and GRU. So in sequential model, this LSTM or GRU can be used, right? Or widely used, models. Even this bidirectional LSTM is there, so we can use that one. Okay. So this is about the present and past. So in the past, we are having a model for a particular data. Now it is not, the technology has changed, the strategy has changed. Now everything is going to be pre-trained model. What we can use for your task is a pre-trained model. It is already been trained. Just fine-tune the model, that's it. So that is the technique that we use in the deep learning model. Already model will be fine-tuned, whether it is image data, whether it is text data. So you just pick the relevant, suitable pre-trained model, fine-tune your that model for application, for your application. Okay, that's very easy. So compared to other models, using fine-tuned pre-trained model, right, is very easy. Just you have to fine-tune, that's it. So that is the present technology that we are using. So that is based on transfer learning technology, right? So transfer learning, you can leverage on already pre-trained model. No need to do once again training. It will take a lot of time. So in order to avoid all those things, just use the training. So this is what another view. So for each and every data, in earlier, in a traditional one, we are having the learning system. But now in this transfer learning technology, what you do is you train the model on data one, and you pass the knowledge. You can use that knowledge to learn data two set. So this passing the knowledge and learning data set two is called as fine tuning. Already knowledge is there in the learning task one. but we want to use it for data set too. So what you do, learning the system task too, we do fine tuning, that we call it as fine tuning, right? So the mantra here is just fine tune the model. Okay, so you'll get the raw data, raw data, pre-train with your own data, that is called as fine tuning, and you can go for inference, right? So you can do a lot of tasks, especially all pre-trained model, whether it's image processing for image classification application, audio, video, even text. You will get a lot of fine-tuned pre-trained model that you can fine-tune. So this is another way. So untrained model, so you will pre-train it, you'll get pre-trained model and then fine-tune for your application. So whatever application that you are having, just fine-tune it to suit your requirements, right? So we are having a lot of models that have been evolved over the years for better performance. Each and every model that was developed at that time was a milestone. It was a groundbreaking model in its own way. And as you know, technology is not stagnant; it keeps on changing. It keeps on updating. So you'll get to see more and more better models, right, with a lot of features, with a lot of applications. Okay, this is Elmo, which is based on character embedding. It's not word embedding. So for each and every character, you can have the embedding, and based on that, it is developed. And this is the BERT model, bidirectional transformer. It is based on transformer, right? Encoder, based transformer. So it is a deep learning model, and it is widely used, and it is thought as a major milestone in the NLP application. It has revolutionized the NLP application. Okay, so these are disrupting technologies that was that evolved. Okay, in earlier in 2017, around 2017. So transfer learning in NLP, yeah. So is equal to pre-training model and fine tuning. So if you use transfer learning in NLP, what you do? You get the pre-trained model and fine tune it. Okay. So this is the BERT model, and this uses a different word embedding. It's having its own embedding. So which is based on the training, right? So you will get all the word embeddings, and for each and every word. So whatever word you give, it will convert into its embedding, BERT embedding, and it can do a lot of tasks. Okay, downstream tasks. So this is the pyramid that we are having. So LSTM was used when to create the, in order to for better performance, in order to have a dependency of the contexts. Okay, long-term dependencies, LSTM were used. They are called as memory networks. Then came bidirectional LSTM. It's an improved version of LSTM, right? And then attention layer, then transformer. In fact, transformer based on attention layer, and we have BERT based on transformer model. So even transformer is outdated. So maybe next wave is going to be on Fourier transformation. So they are working on that to create model based on Fourier transformation, right? So right now, we are having models based on transformer, which is much more efficient compared to all other sequential model or memory networks. Okay. So BERT was a very important milestone in that evolution. So you can see the BERT layers. We are having a number of layers. So fine tuning will going to just change the layers right at the bottom, right, and you can able to carry out the the classification. So you can see the layers, and whatever you get at the end. So at the end, whatever you get, that will be going to be used for classifier. That will be the summation of the entire sentence. So this vector, that what we get at the end, is going to be used for classifiers. Okay. So that is, that is the layers that we are going to use for in the BERT, okay, for the input. So it is having three embedding layers: token, sentence, and transformer. So these are the cloud for the cloud of different models. You can see a BERT model. It is having so many variants are there. You can select video BERT, bio BERT, sci BERT. BERT itself is having huge, and we get so many varieties: base, medium, and then large. So these are the results that we got, okay, using BERT. You see that in a multi-class or binary classification, it is doing, it has given a very good results, over 90 plus, okay. And this is how it is evolving. So you should have the knowledge of landscape of NLP. You can see here the Microsoft NLG. It is having 1.7 billion parameters. Billion parameters means, see, in neural network we have parameters, the weights. So the weights should be learned. Here, the weights are 1.7 billion parameter. Okay, weights are parameters. So BERT is somewhere here in 2000, October 2018. It actually, it was developed, right? So if you look at this, the BERT is nothing, okay, in front of this NLG. So your see, latest we have added GPT-3. So that can that is making news, lot of news. That is the talk of the town. So these are some of the Python libraries that we can use for text processing, and they all support deep learning models, especially Keras. They're supporting word embeddings. Okay, so you can select all these things for doing your application. So application is there already. Just borrow that, copy paste, and use your data. So these are some of the libraries that can use for generating word vectors, word embeddings. And finally, as I said, let me show you the demo. So these are some of the application that we are having, using this NLP chatbot. You can do language translation. See, all of these application, still needs, greater, performance. Still, there are many open challenges in all of these domains. Whether you take chatbot, question and answer, sentiment analysis, and now if you look at the trend, so everything is based on deep learning models only. Select what is best one for your application, and try to implement the application on the model. So go for deep learning. So it is freely available. So just fine tune that one to suit your requirements, and if possible, try to invent new application on top of pre-trained models, right? So there are a lot of opportunities there. Sky is the limit. Now you can develop innovative application in all of this using these models. Okay, if you have creative ideas, definitely you can convert that into technology, and you can make money out of those technology, right? So guys, let us see some of the applications that I am going to show for you. So let me take you through the browser. Hope you have understood the at least some glimpse of the text processing framework. So any questions you are having? So we'll see demo, and it's very interesting. If you look at the how system is going to perform. So let me show you the demo for this one. Let me prepare for the demo. Hope can you able to see the browser? So let me change this browser. Now, can you able to see the browser? Give thumbs up. Huh?
Yes.
Okay, browser. So here I'm going to give the question and answer. Okay, it is going to use a BERT model. You see the BERT model, and you will be amazed to see the response, right? So let me give the context. So I will take the context. So this is the paragraph that I have got from my website about my college, right? So this is the context, because you have to give the context in which you can ask question and answer. See, it is going to ask the corpus or the text, so that we call it as context. Okay, so I will going to set the context, right? Okay, I will set the context here. So hope you are seeing my screen. So this is the paragraph that I took from the website, my college website. And now I will going to throw the questions. I will give the questions one by one, and see the answer, see the results that it is going to give. So who adds VVC? There is no sentence like who adds VVC. Just I'm giving this statement. Excuse me. So this will going to analyze. This will compute the sense. What is the sense? What it is talking about? What is the question? And from this, it will going to get the answer. There is no specifically explicitly I have mentioned like who adds VVC or VVC is added by, it's not, there's no such sentence here, but still it can able to get a very good answer from this one. Okay, just I will going to give the submit the question, and you can see the answer is going to be obtained here, and this is a single word answer that you can get using this question and answer. So what you're supposed to you can do here is, so you can build chatbot using services at the back end. So you can install or you can get a paid service, and you can set the context, and you can develop chatbots for the particular application. See here, B Sada Shive Gowda. That is the principle. In fact, it is correct answer. Who adds VVC? Vidyavardhaka College. Not even I have expanded. Just who adds VVC? No, it is B Sada Shive Gowda. Nowhere here I have given VVC is added by Professor Sadashiva Gowda. Nowhere here it is mentioned. But it will compute the sense. It will understand what is the question and its sense. And based on that, it is going to give the result. Some more questions I will going to pose, right? What is the full form of VVC? So there is no such thing in this case, right? VVC stands for our VVC. So what is the full form of VVC? It's a typical question, even though it's a very simple question. You can see here the answer is correct. Vidyavardhaka College of Engineering. Okay. Some more questions, some more difficult questions. Okay. And courses, what are the courses it is going to offer, right? So what are the courses it is going to offer, right? You can see our UG programs, 3 PG programs, and 9 research center for pursuing PhD. So just I gave just courses. What are the courses VVC offers? There is no statements like VVC offers or something like that. So it is there inside this one. It is try to analyze the meaning of each and everything, and it has got the output right with reasonable probability. This is the probability that it has generated, right? So likewise, last question. Let me show you what is the work of VVC. Just what is the work of VVC? So what is the work of VVC? So it is going to give the answer based on the context. See here, impart quality education to all section of society. It is nowhere VVC works for, or the work of VVC is that is not specified. That is not explicit here. But even though it is, it can able to get a answer. It can tease information from this context. Okay. So hope you have understood. Likewise, you can have many, demos that we can have, like sentiment of the text, right? You give any, sentence, it will going to give sentiment of the text, whether it's positive, negative, so reasonably well, right, can perform. And once again, thank you, right, for your patience listening. So now I'm ready to take questions. I hope you have understood some insights into the text processing. Hope you have understood what is the importance of deep learning models in NLP. So now we are in the era of deep learning models. So each and every NLP, I think it's based on deep learning. You will get better performance. Okay. So let me conclude by saying thank you for your patience listening, and also thank you for the opportunity extended for me on this occasion to share my knowledge with you all. Thank you once again.
Thank you for Dr. Paramesha for material. And now we have first question from Mrs. Rajesh. Is it okay?
Okay.
Yeah, thank you so much. Oh, no, sorry.
Correction, Miss Novita. I'm not Mrs. actually. I'm a Miss Rajeshwari. Okay. Hello, sir. I think Dr. Paramesha is new. Hello.
Yeah, you can.
I think Dr. Paramesha mic is muted. Miss Novita. Okay. I would like. Okay. Shall I ask now? Okay. Sir, I have questions actually. In image classification, it takes a weight of each image from data set, especially in training data, and it went through feature learning. Before that, it should wait a minute, sir. Okay. In image classification, it takes a weight of each input from training data. And before it enters to a fully connected layer, it should be converted to vector. So, but in NLP, I still get confused, sir, because you said that the word will be converted to vector, but at the end.
I understood your question. Okay. So let me reply to that. See, Rajeshwari, so actually when it comes to image, image should be, it's having a lot of pixels. The resolution is going to be very big. You cannot directly feed the image to neural network. So what you can do here is you can do some convolution operations, bring down the size, say from 100% to say 40%. And then you can feed to the new fully connected layer for downstream classifications tasks, right? So you can use convolution layers. A lot of convolution layers are available. You can do it. So it is better if you go for convolutions. Direct feeding or extracting characters. Extracting features from the image. It's not, it was a classical method. Now you are going to have the deep convolution neural network. Go for convolution and fully connected layer. That's it. And also you can use pre-trained models. Pre-trained models are available. You can use it for different classification. If you are doing it by yourself, it will take a lot of time, effort, and training is required. A lot of training is required. Already pre-trained models are available. You can just use that, pick the right model and integrate it to your application. Right? That is the better way, good way for doing your application. Yeah.
Okay, so if we want to use a pre-trained model, so we have to fine tune it, right? So how to
fine tune it. You have to train on your
how it works actually. I would like to see that if you want to show maybe how to fine tuning.
Just train that on. Use the model. You give the training data one by one, and you set the batch, and you set the the last, what is the last function and all. So that's it. So model is already there. Just in the instructions, you just fine tuning. You are writing a program. You are not doing it. It's not manual. It is you are programmatically you are doing it. So you give your input, and you set what is the last, what is that number of iteration and all. So that's it. Just one program about 20 lines or maybe 50 lines maximum. That's it. You are done with that. Okay. Your training, fine tuning can be done.
Okay. So is there any website reference to get pre-trained model?
No, lot of you just give pre-trained.
In Kaggle maybe. Kaggle?
Yeah, Kaggle you'll get lot of resources, and also you will get Keras framework, the Python programs based on Keras.
But the most powerful is TensorFlow, sir.
You can do it. TensorFlow also you can do it. In fact, Keras, it is going to work on TensorFlow only. The layers, right? You can use TensorFlow, no problem. No problem.
So, did you ever heard about graph algorithm in NLP? Graph algorithm?
Graph algorithm? No.
Okay.
NLP, in which...
It actually can create a new output from a previous...
Yeah, that's what I don't know exactly.
It is most common. It is most familiar. It is most famous.
I have used transformer. See, I have not gone to machine learning and all.
Okay.
I have other areas. I have used traditional machine learning and other algorithms based on trees and all. So this BERT model and all, you can use it. You can develop your own models for machine translation. It is possible. So you can use from your Indonesia to English, translation. It can use. Thing is, you need data set.
Yeah,
data set
it is true.
Yeah.
Okay. So you said that we can predict next word based on previous word. So is that mean it's not a implementation of graph algorithm? No.
Yeah. Right now, models what we can access for our in our system is BERT model, BERT based models, right?
Okay.
And if you go for higher models, you cannot do it. You cannot load it on the system. only you can use it as a service. Now that is the thing that is happening in the industry. Next wave is going to be everything is based on service only. So they are converting everything into service, paid service, maybe free service or paid service. So if you want to do some task, you just send the data. They will do it for you and they will send the output. So that is a trend that is happening. You cannot create those models in the lab or in the educational institution of your scale. It is not possible, right? And technology, the next wave, it is going to be 4-year series, 4-year transformation. Now we have a transformer based on attention. Now it is going to be 4-year transformation. So it is 4-year transformation is, they are using it. They will going to use it, and that will be the next wave. Okay, you will see a lot of different technologies in the landscape. What you are saying, what we studied 6 months back, it's already outdated, right? So the talk of the town is GPT. I think GPT award 3. Now still better models are evolving. Every fortnight you will going to see different models that are being developed for applications. Okay, BERT model is already outdated, but since it is accessible, which is freely available, you can download it, you can use it on your system. We are using it. Otherwise, there are better models that we can use, right? So NLP, they are the landscape, everything has been changed. No more it is going to be on our system. It is going to be on cloud. Everything is going to be on cloud only. You have to pay for the service. That is what they are creating.
Sir, one more maybe. One more. Okay, sir. In image classification, especially using deep learning approaches, it needs a high consume of GPU. How about NLP? It is the same.
What?
In image classification, especially if we are using deep learning approaching, it needs a high consume of GPU to train the data.
GPU, you need.
How about NLP? It is same or?
It is required because you are developing. See, BERT model, it works on GPU only. GPU. If you do it on CPU, it will take hours together for training.
Okay.
So for your part, your part is going to be fine tuning only. So most of the thing is going to be fine tuning only for your part. No, they have made it like this. That the models are such a way that only fine tuning is required. What is your data? For your data, say for your institution, if you want to do chatbot, you give what is the data relevant to your institution. Right? University data and all. How many seats are there? How many courses are there? Each and everything, for that you have to train, right? For the model. So for that you need online platform, like cloud, better cloud infrastructure is required. If you have institution, if you are having a GPU based, setup, you can do it. So if it is not there, then you have to rely on cloud only. Right?
Okay.
So even in a image processing, NLP, for all these data intensive applications, you need GPU, right? Or TPU you can have. Okay, that is again a hybrid version. Okay, TPU. So Google, it is there, 15 GB TPU free of cost. Colab, it is there. If it is workable, you can go for that, or else you have to go for cloud. Okay, set up the system, virtual system, and do over there. Okay, for that you need credit or some pay. You need to pay, right? Yeah.
Can I have one more question?
You can. Yeah, last.
Okay, sir, we can do image classification actually in ML. Actually, deep learning is the subset of ML. But what is the difference about using ML and DL?
See, ML is machine learning, which is for the structured data, right? Structured data. If you are having structured data, then it is ML. If it is unstructured data, then you go for deep learning. So deep learning requires ML, that is neural network plus algorithm. So that is the basic idea of using deep learning. So their features are learned automatically. So if you use convolution neural network, it is very easy. So, and then you can go for fully connected layer. So in the deep learning models, it is going to be for unstructured data, not for structured data. Even structured data, if it is lengthy, the data is very having more dimensions, then you go for deep learning. So when data is more for unstructured data, then deep learning models are suitable. For ML, only structured data, numerical data with lesser dimension, it is suitable. Okay. Yeah.
Okay.
Unstructured data, deep learning. Structured data, ML. So deep learning is not substitute for ML. ML will not be substituted by deep learning. But since dimensions are more, because in NLP we are having word embedding. Each word is having nearly 300 components, right? So vector of 300, size 300. So processing that one requires a lot of effort, lot of training is required. So you need deep learning techniques, right? LSTM, they are all deep learning based techniques. Okay.
Okay. Thank you, sir, for answering. Thank you.
Which semester you people are studying? Which semester?
I'm a fourth semester.
Fourth. Okay.
In
Still,
information.
you acquire skill sets. You acquire skill set, in the next another
Actually,
1
I'm
year.
self-learning, sir.
Yeah.
Self-learning. Yeah.
No, okay. You acquire skill sets, and in pre-final year or final year, you may get opportunities. Okay. So you need to acquire skill sets, some theoretical background you should require, and for doing all the deep learning tasks. It's freely available. Codes are available. Lot of things are available. You can do it.
Sir, is in Vidyavardhaka College actually has a curriculum about AI like this?
Huh?
In Vidyavardhaka, yeah.
Huh?
Is in Vidyavardhaka College has a curriculum about AI for undergraduate program? Yes. No.
Which one? Training program.
In Vidyavardhaka College, do you have a curriculum about AI in undergraduate program?
Yeah, we are introducing AI and first Python, AI, and machine learning into segments. Yeah, we are planning. We are having separate batch. Yeah, we are having AI and machine learning branch is there. I am actually in CS branch. CS means mixture of all type. We are not concentrating only on AI ML. We are having other fields, web development, then other automata theory, networks. We are concentrating. It's like general branch.
Okay. Okay.
So we are having AI. You are having. We are introducing, and in the third semester we are having deep learning. For MTech we are having deep learning.
For MTech.
Yeah.
Okay. Thank
now
you.
We
sir.
are we too have introduced.
Okay. Thank you, sir.
Thank you.
Novita, ma'am, I'm finished.
Yeah. Thank you for Miss Rajas. Thank you for Dr. Paramesha. I guess no one else asking. Sorry. I continue the session closing, sir.
Okay. No.
Yeah.
You can conclude. You can conclude. Madam, you can conclude.
Kakak bisa buat kesimpulan, Kak. Kalau mau kasih kesimpulan.
Okay.
I don't have.
Thank you for the opportunity. All the best for all of you. All the best.
Thank you so much, Dr. Paramesha, for your knowledge. Thank you so much, and I hope we can meet again in other event. Thank you. Goodbye. Thank you for our audience. Thank you everyone for coming this event. Thank you.
Thank you.
I'm sorry, I will take some screenshot during this meeting.
Oh,
1, 2, 3, and cheese.
orangnya udah nggak ada, guys.
Oke, nggak apa. Nanti jangan langsung ditutup ya, nah.
Hah?
Enggak, nanti kalau nanti selanjutnya jangan langsung ditutup.
Okay, next time Bel will spill. Okay, thank you.
Thank you.